In automotive coatings, the logic of system-level approval is fundamental to OEM quality, durability, and process robustness. Unlike decorative paints in other industries, automotive coatings are not standalone products. They are interdependent layers that work together to deliver appearance, corrosion resistance, and long-term performance. Understanding this principle is essential for anyone involved in coatings, RD&I, formulation, or process engineering. OEMs approve coating systems, the integrated stack of pretreatment, primer, basecoat, and clearcoat, because the performance of one layer depends on the properties and behavior of the others. Interlayer adhesion, for example, is not determined solely by the primer or basecoat chemistry. Adhesion depends on chemical compatibility, solvent interactions, and mechanical properties across layers. A weak or incompatible combination can result in delamination, even if each layer passes standalone tests. Chemical compatibility is another critical factor. Solvent-based coatings are dynamic systems where solvent evaporation, resin swelling, and interdiffusion influence how each layer bonds to the next. A change in the basecoat solvent profile can alter the swelling of the underlying primer, affecting flow, leveling, and even metallic orientation. Similarly, the primer chemistry must be compatible with both the substrate and the applied basecoat and clearcoat to maintain adhesion and prevent defect propagation. Mechanical interactions between layers further justify system-level evaluation. Each layer contributes to film flexibility, hardness, impact resistance, and stress distribution. Incompatible mechanical properties can cause cracking, stress delamination, or solvent popping. These interactions are particularly critical in high-performance or complex effect coatings, where small deviations in viscosity, solids content, or film build can magnify defects. OEMs also differentiate laboratory qualification from production validation. While a coating layer may perform well in bench scale tests, only full system application under production conditions demonstrates real-world robustness. RD&I teams assess the coating stack under actual spray parameters, flash times, bake cycles, and line speeds to evaluate risk, process window, and defect sensitivity. Accelerated durability tests, corrosion panels, and adhesion trials across multiple layers simulate the stresses vehicles experience over years of service. From a system-level perspective, modifying a single layer is never isolated. A seemingly minor change in primer rheology or basecoat solvent balance can influence metallic flop, intercoat adhesion, solvent popping, or overall durability. OEM approval ensures that each layer is optimized and validated as part of a coherent, integrated system, minimizing field failures and maximizing consistency across millions of vehicles. In summary, OEMs approve coating systems, not individual paints, because the interplay of adhesion, chemical compatibility, mechanical properties, and solvent interactions defines performance. Laboratory tests alone cannot capture these dependencies. Full-stack system validation under production conditions is essential. For RD&I engineers, understanding these system-level cause-effect relationships is critical for risk assessment, formulation decisions, and long-term durability assurance. If you have unresolved questions about system-level coating interactions, interlayer defects, or OEM process challenges, share them in the comments for discussion in future episodes.